So on this class opener, we're going to kind of review everything, all the key concepts of simplifying radicals. And the very first thing you need to know to be able to simplify radicals are your perfect square number list. So everybody should know this list: 4, 9, 16, 25, 36, 49, 64. You could write the number 1, but that's kind of pointless. We don't use the perfect square number 1 to simplify radicals, to simplify square roots. So that is the list that you need to know. You need to know how to write it, how to come up with it. How do you come up with 4? 2 squared, 3 squared, 4 squared. That's why these are called perfect square numbers. Okay. Now, once we start simplifying, it's this easy, guys. When you take the square root of one of these numbers, it's a nice, beautiful answer. So that's why number 2 is what?
7.
The answer is 7, because when you take the square root of a perfect square number, you get a nice, perfect answer. So everybody on number 2, you should write down 7 as your answer. Okay. Now, number 3, it's saying the square root of 45, and 45 is not up here, huh?
No.
And so that means 45 is not a perfect square number. You want a perfect square number. So if you don't have a perfect square number, you're going to rewrite it with multiplication to get a perfect square number, right? So 9 times 5 is what you really want to do. Okay, so this, and before I even write down number 3, let me zoom in on number 3. Before I do number 3, I do want to say that the key concept is this. When you have the square root of a number times another number, you could rewrite it as the first number times the square root of the second number, right? You're able to split the root. That's the key concept, the main point that we need to learn today. Or not today, but in this lesson that we've been doing for a week already. So, Davian, 49, since it's not a perfect square number, we're going to rewrite it to become 9 times 5. And the reason why we want this 9 right here is because 9 is a perfect square number. It's up here on your perfect square number list. So when you split it, when you apply the key concept, you do the square root of 9, the square root of 5, you'll get the answer 3, because the square root of 9 is 3. And the square root of 5, you simply leave it. Okay, whenever you can't break it down any further, you just leave it like that. Okay, so that's your answer to number 3. I hope everybody understands that. Everybody does, right? Okay, let's move on to number 4. Number 4, we have the square root of 7 times the square root of 7. And right here, what we're going to be doing is applying the key concept backwards, right? When you have the square root of A times the square root of B, you could put them together. That's the key concept backwards as the first number, A, times the second number, B, within one radical. So what is the square root of 7 times the square root of 7?
7.
It's going to just be 7 at the end of it all, right? So the work would be to put them together, 7 times 7, and the square root of 49 takes you back to 7. So you don't need to show this work, because throughout the past couple of days we said that whenever you take the square root of something and multiply it with that same exact square root value, the square root disappears and you end up with just the value, right? The square root of 5 times the square root of 5 is what? 5. The square root of 13 times square root of 13 is what? 13. The square root of happy face times square root of happy face is what? Happy face. No, not sad face. Happy face, because you know this stuff. It's only sad if you don't know it. Number 5, we're going to use that same key concept backwards, and we're going to put it together. Now, that's not the only way you could do it. I mean, you got to ask yourself, could I simplify this? No. Could I simplify this? Yeah, I could break it down to 4 times 2. But instead of that, let's use this key concept backwards, right? Let's take these separate roots and put them together and multiply them. Now, why would I do that? Because when I put them together and multiply 2 times 8, what do I get? A nice, beautiful, perfect square number, which means that the answer is what? 4. Ta-da. Okay. Let's copy down the rest of these. Well, not the rest, but the next couple. We have the square root of 6. I mean, not the square root of 6. We have number 6, which is 3 square root of 25. Now, this brings up the next idea that we had last week. If you have a number outside of your radical, first just deal with the radical, and then whatever is on the outside of the radical, multiply it by 3. Because after all, this does say 3 times the square root of 25.
3 times 5.
Yeah, so it's really 3 times 5, which is 15, right? So once again, guys, it's kind of like if you were to ignore this 3, all right? And you work on the square root of 25. The square root of 25 is 5. And of course, you're multiplying right there, so you're multiplying right here. And that 3 is simply going to come down, and it's 3 times 5, which is 15. What do you think? Easy peasy?
Yeah.
Lemon squeezy. Number 7. When you have a number times a radical, that's exactly what we're doing. We're multiplying, and then times the number 3, and then times the radical square root of 32. Now, you could simplify the square root of 32, and then get whatever number you get on the outside, multiply it by 3, and you'd still have radicals. Then you'd have to multiply numbers with numbers. I would first start by taking the square root of 2 and multiplying it by the square root of 32. In my head, I would double 32. 2 times 32, what do I get? 64. Now, is 64 a good number to have in the square root?
Yes.
Heck yeah, right? So let's do that. When you see, like if I would have multiplied 2 and 32 and it wouldn't have worked out, then maybe I wouldn't put them together. But right here, 2 times 32, that's 64. And I know that that's a beautiful answer. So let's rearrange this. This 2, I write it right here, times this 3, I write it right here. And then when I put this one and this one together, we said it was going to give us a square root of 64. Right? 2 times 32 is 64. So let's continue working here. 2 times 3, that is 6. And what is the square root of 64? That is 8. So I really have 6 times 8, which is 48. So 48 is the answer right there. Let's move on to number 8. So right here, I could do 2 times 10 and get the square root of 20. Or if I don't want to do that, I could simplify the square root of 10. Actually, I can't simplify the square root of 10. So I guess I am stuck multiplying them together. So let's do it. The 3 and the 2, those numbers that are on the outside, let's put them together, 3 times 2. And then let's put the square root of 2 times the square root of 10 together. Square root of 2 times the square root of 10. So now let me actually multiply. 3 times 2 is 6. And the square root of 2 times the square root of 10, when I put them together, that is a square root of 20. So is that our answer?
No.
The question is, could I continue doing something here with the square root of 20? Yes. Right? Now, would it, let me ask you this. Is 20 a perfect square number?
No.
No, it's not. Could you rewrite it with multiplication to get a perfect square number? Yeah. You're not going to go 2 times 10 because 2 is not a perfect square. 10 is not a perfect square. I mean, look at these. These didn't help us. 2 and 10 didn't help us at all. But when I go 4 times 5, that's a different story. Let me go 4 times 5, and let me split the root. Okay, now the 6 comes down. I'll even write it over here. 6 times, now the square root of 4, that is 2. And the square root of 5 is going to stay the square root of 5. So what's our final answer, number 8? 12 square root of 5. Okay, so whenever you have numbers and radicals, put the numbers together, multiply them, get a number. Put the radicals together, especially if you can't do anything with them, multiply them, and then try to simplify that radical answer, that square root answer. The next main concept or idea that we learned last week was, it's the same key concept that you're able to split the root, but instead of multiplication, we have division, right? Let me write it right here. If you have the square root of a over b, you could split it to the square root of a over the square root of b, right? So it really becomes like 2 problems. So what's the answer to this one? 3 over 5 is the correct answer. When you put when you put the square root of 9 over the square root of 25, we split that root, and well, the top answer is 3 and the bottom answer is 5. 3/5 is the answer. Let's move on. Number 10. This one's a little interesting, a little more interesting. Hopefully you guys are keeping up with this. So we're going to split the root, the square root of 1 over the square root of 3. Could I do the square root of 1? What's the square root of 1?
1.
It's just 1. So on the bottom, I still have the square root of 3, but there was that detail that we learned last week, Isaac, that you do not want a radical in the denominator, right? You do not want a radical in the denominator. And we also knew from last week that when you multiply a radical with itself, the radical disappears, right? And it's just the value inside of the radical. So we know that if we multiply both top and bottom by the square root of 3, 1 times the square root of 3 up on top, well, that's going to be a square root of 3. But on the bottom, the square root of 3 times the square root of 3, what's that? That's just 3. And ladies and gentlemen, that's your answer, the square root of 3 over 3.
Wait, so since
All right. That was number 10. Number 11. This is one of the last concepts we learned. And the main idea that we learned at the end of last week was that a square root could be rewritten as the power of 1/2, right? A square root could be rewritten as the power of 1/2. So that's something very important, because that means that this square root right here, you could rewrite it as the power of 1/2. And inside the parentheses, you're going to have the x squared that was on the inside of the radical, okay? Now, when you do have a power to a power, you multiply. So in other words, this square root, whatever power you have, you're going to end up dividing it by 2. So you want even powers in there, okay? You're going to end up just dividing this by 2, because 2 times 1/2, what's half of 2? It's just 1. So if you divide this by 2, it's just 1. So here's our answer, x to the 1. And the 1 is not even necessary. You could just leave it as x. And that's your answer to number 11, right? Now, you didn't even need that truth. I mean, that truth is important on the rest of these problems. But we also knew last week that a square is the opposite of a square root. So a square root and a square, they undo themselves and you just get x. But another way of looking at it, a more important way of looking at it, is that a square root is the power of 1/2. And a power to a power, you multiply. So you're going to end up just taking half of whatever power you have in there. Let's move on to number 12. What's the answer to that one?
4.
Is it x to the 4th? Okay, what did we just say on the previous problem? The square root is, it's the power of 1/2. So that means you're going to be dividing. Now, I put this one here on purpose, guys, because so many of us are like, oh, I know the square root of 16, it's 4. So we say x to the 4th, and that's wrong. Because remember, the square root is the power of 1/2. So you really have x to the 16th right in here, to the power of 1/2. You're multiplying by 1/2, which is really just taking this 16 and dividing by 2. So the correct answer is x to the what? 8th. Don't forget that, guys. It's too easy to mess up on those problems on the test this Friday, okay? Let's not mess up on that. A square root is really the power of 1/2, simply dividing that power by 2. So it's awesome when we have even powers, right? When it's divisible by 2, it's easy. 16 divided by 2 is 8. Now, look at this next question. 17 is not divisible by 2. It's not an even number. It's an odd power. We want an even power. So what we're going to do is we're going to rewrite it. We're going to rewrite it. Instead of x to the 17th, we're going to write it as x to the 16th times x to the 1. Right? You're always going to do this. When you have an odd power, you're going to have to rewrite it as the even power right before it, and then another one of those x's or another one of those y's. Right? That way, when you split the root, now you could actually get the answer to this one. What's the answer to this one? X to the 8th. All right? So we have x to the 8th. And the other one, the square root of x to the 1, you don't even need that one. What is the square root of x? You can't really do it. You just leave it, the square root of x. So ladies and gentlemen, that is your answer right there. X to the 8th, square root of x. Yeah, it looks weird, but just think about it. If you have an even power, then you'll just divide that power by 2 and you'll be done, right? What's the square root of x to the 10th? Square root of x to the 10th. X to the 5th, right? But if you don't have an even power, then you're going to have to split it, get your even power right before that one, and put one more x, right? That way you could get an answer and this square root of x stays. Let's move on to the next one related to this. We're getting to one of those harder type questions that require multi-step. Now, keep in mind that on the inside of this radical, all you're doing is multiplying, right? Okay? And we love having even powers. Even power there, even power there. Right here, the y to the 1, that's not an even power, and we can't rewrite it to get an even power. So we know that this is not, we're not going to be able to do the square root of y. It's going to stay the square root of y. But anyway, let's start by making this a little easier by splitting that root to each and every part of this monomial on the inside. So we have the square root of 9, we have the square root of x to the 4th, we have the square root of y, and we have the square root of z to the 8th. So what it really becomes is 4 simple problems, all right? Could you do the square root of 9? Yeah, it's 3. Could you do the square root of x to the 4th? That's half of 4, which is x to the 2nd. That's right. Could you do the square root of y? No, that's just going to stay the square root of y. But could you do the square root of z to the 8th? You get z to the fourth. Z to the fourth. And what about that square root of y that we couldn't do anything with? Let's just bring it down and put it at the end, right? So you see that one ugly looking problem, you can make it into 4 simple problems and just split the root and work on each of them at a time. Let's move on to the last nastiest question right here on this class opener. Then we'll be able to move on to the next part of class. Right here, what would you do? Break it down into smaller radicals, right? So let's do that. Let's write down the square root of 18. Let's write down the square root of x to the 5. Let's write down the square root of y to the 10th. I'm happy with that one, y to the 10th, because that's easily divided by 2. But the square root of z to the 7th. This is an entertaining question. The easiest thing to do out of these 4 little problems, the easiest one is which one? Y to the 10th. What's the answer there when I do the square root of y to the 10th? Y to the 5th. Yeah, perfect. You just divide it by 2. Now these other ones require work, right? Like 18. 18 is not a perfect square number. I need to rewrite it with multiplication to get a perfect square number. Would it be a good idea to do 6 times 3? No. Okay. What do I rewrite it as? 9 times 2. If it's not a perfect square number, let's rewrite it with multiplication to get a perfect square number. That way, when you split the root, you'll be able to do the square root of the perfect square number, which is 3. And the square root of 2 just comes down. So that's the answer to the first one, square root of 18. For the x to the 5th, I need to rewrite it as what? X to the 4th times x to the 1, right? Perfect. Perfect. That way, when you split it, I'm just going to do it right here. Split it, the square root of x to the 4th is what? X to the 2nd. You simply divide it by 2. And the square root of x is what? The square root of x, right? So how about that z to the 7th? That's the last part over there. Z to the 7th, I'm going to rewrite that as what? Z to the 6th times z to the 1st. And we're going to split the root. That way I could do the square root of z to the 6th and get what? Z to the 3rd. And the square root of z to the 1, that's just going to be the square root of z. So, ladies and gentlemen, all of this is our answer. It's just kind of messy. Got to clean this up. What do I mean by that? Let's first put the answer with all the terms that are outside of the radical out here, and all the terms that are inside of the radical, let's put them together underneath one radical. Okay? So what's our final answer going to be? Start with the number 3. Okay? Because see, it says 3 times the square root of 2 times x squared times square root of x times y to the 5th times z to the 3 times z to the square root of z. So let's rewrite everything that was on the outside. We have the 3. How about that x squared? Bring it down. How about that y to the 5th? Right there, bring it down. How about z to the 3rd? Bring it down. Now what's left inside the root? The x and the z. Oh, and the 2. Thank you very much. I totally forgot about this 2. So we need to take that 2 and put it right there. Let me do that just by putting a red 2 right there. That's ugly. Maybe I should rewrite this whole thing, huh? Just put a 2. That's still ugly, but you guys get it. I mean, I made a mistake right there. I forgot about this too. So don't make that mistake when you're taking the test. And that's pretty much everything with regards to simplifying radicals.